Newton's law of octaves. This was yet another attempt to classify the then known elements. So Newton did two things. First, he arranged the elements in the increasing order of atomic masses. Increasing order of atomic masses. So in this manner, he increased all the known elements in the increasing order of the atomic masses. And then he found that every eighth element, the properties were similar to the first. Are similar to properties of the first element. What does that mean? Suppose we start with the first hydrogen as the first element. So we have 1, 2, 3, 4, 5, 6, 7, 8. Fluorine and hydrogen will have same properties. Now we start with fluorine. So we take fluorine as 1, then 2, 3, 4, 5, 6, 7, 8. Now chlorine also will have similar properties. Next, suppose we start as beryllium as 1. Which will be the next element which has similar properties? Beryllium 1, 2, 3, 4, 5, 6, 7, 8. Beryllium and magnesium will have similar properties. Then to find the next, I start with magnesium 1, 2, 3, 4, 5, 6, 7, 8. Calcium. So all these beryllium, magnesium, calcium will have similar properties because they are the every eighth element. Let me start with lithium as the first element. Which will be the next element that has similar properties? 1, 2, 3, 4, 5, 6, 7, 8. Sodium will have similar properties. Now to find the next, I start with sodium as 1, 2, 3, 4, 5, 6, 7, 8. Potassium. So lithium, sodium, potassium all will have similar properties. So the properties of every eighth element are similar to the properties of the first. But what is important is you need to arrange your elements in increasing order of atomic masses. Next, why was it called octave? It was just like the notes in music. We see the notes of music are just like this. You have 1, 2, 3, 4, 5, 6, 7, and then we get do again. So it repeats. Every eighth note repeats. Just like here, every eighth element repeats. So hence the name, the law of octave. It shows some similarity to the notes of music. So here's a picture of Newton's octaves. These are the notes of music. Do, re, mi, fa, sol, la, si, and that is 7 notes. And when we start with hydrogen and we count 8, we have hydrogen, then we have 1, 2, 3, 4, 5, 6, 7, 8. Fluorine will have similar properties. Similarly, if we start counting from say beryllium, or say boron here, we count 8, 1, then 2, 3, 4, 5, 6, 7, it will come to aluminium, the 8. Then same thing if we start with nitrogen, the next 8th element will be phosphorus. So this was Newton's law of octaves. Now there were some drawbacks though in the Newton's law, and the drawbacks go this way. First is, it was found that a law of octaves was applicable up to calcium, only up to calcium. After calcium, every eighth element did not possess properties similar to that of the first. That was the first drawback. Then the next drawback was, Newton assumed that only 56 elements existed in nature and that no more elements would be discovered in future. But later several new elements were discovered whose properties did not fit in the law of octaves. And then In order to fit the elements into his table, Newland adjusted two elements in the same slot. But he also put unlike elements under the same note. Like if you see cobalt and nickel are in the same slot as fluorine, chlorine and bromine. Let's look at that. Look at cobalt and nickel, and remember cobalt and nickel are metals, but they occupy the same slot as hydrogen, fluorine, chlorine and bromine. And hydrogen, fluorine, chlorine and bromine are non-metals. Their properties are completely the opposite, but they were put in the same note. So this was one of the drawbacks. Next drawback was iron, which resembles cobalt and nickel, were placed far away from each other. Here was cobalt, nickel and iron was here. They should have been in the same group because they had similar properties, but they were kept away from one another. And this Newland law of octaves, they worked well with lighter elements till calcium, and after calcium it did not work. So as the heavier elements came in, it did not work. But there was an advantage of Newland over Daubigny. Newland's law of octaves included many more elements as compared to Daubigny's triads.